Right, so in this question, we're asked to find the time taken for the acceleration. Okay, now the acceleration is sort of the second phase of this journey. Okay, because it decelerates to start with, doesn't it? Because it starts. We look at the journey where it's at 18 meters per second, and then it decelerates for 9 seconds until its speed is 12 meters per second. Then it starts to accelerate, and that's the bit we're interested in. So when it starts to accelerate, okay, we know the speed of it is 12 meters per second. Okay, so we can write u as 12. All right, that's the initial velocity. The train then accelerates at 0.5 meters per second squared. Okay, until it reaches a speed of 22 meters per second. So final speed will be 22 meters per second. And we're asked then, as it says, to find the time taken for the acceleration. So using v equals u plus at, okay, we can then sub in the values, 22 for v, u is 12, and a is 0.5 times t. Okay, so we can determine then what the time is. Take the 22, take the 12 over, so that becomes 10. And then to get time, then of course you've got to do 10 divided by 0.5 t, so that will be t equals 20 seconds. Then it says to draw a sketch of the velocity time graph for the journey between A and B. Okay, so we get our axes drawn. The velocity time graph. So we don't forget to label them first, right, before you do any graph drawing. Label the axes, put the units in to ensure you get the marks for your sketching. So let's pick up this journey. So it says it's 18 meters per second, isn't it? Is this starting velocity when we pick it up, okay, at point A. Then decelerates for 9 seconds, so maybe we'll have 9 seconds here. Okay, and it decelerates to a speed of 12 meters per second. So if 18's there, say 10's about, say there, so 12's about here. Okay, so we want to get right, so that's where it's going to be after 9 seconds, and we at the start it was traveling 18 meters per second. Now it'll be 12 meters per second after 9 seconds. So once the speed is 12, then it says the train then accelerates 0.5 meters per second until it reaches a speed of 22. So if we've got 18 there, say 22 is going to be about there. Okay, so it's going to now accelerate. And the time it takes to accelerate, of course, we worked out in part A to be 20 seconds. We need to add 20 seconds onto that. Okay, so my scale might not be perfect here. So maybe we'll put 20 seconds there. So that'll be 29. If we add 20 seconds on, and the speed, of course, is going to be 22 then. So if I just draw a line across here. Join that point up there. Okay, so it gets to a speed of 22, and then if we read the question further, it says for the next 31 seconds, then the train maintains this speed of 22 for the next 31 seconds in which it passes point B. So 31 seconds more than we need to have it maintained in this speed. So my scale isn't going to be perfect because another 31 seconds added onto that will take me to 60 seconds. So I can't quite get the scale looking perfect, but it doesn't matter, right? Okay, I've done my best, and the main thing is I've got the numbers all in the right place. Okay, and the graph looks good. Okay, so we don't need that little bit at the end there. And we're done, right? We've got it to 60 seconds. Our VT graph is complete.